All right, thank you so much to the organizers. It's a pleasure to be here. So I'm going to talk about work that is joint with Josh Lerner, who's happily right here, along with Henry Manley and Heidi Williams. So this is our work. We call it The Wandering Scholars, Understanding the Heterogeneity of University Commercialization. And so in this paper, what we're really interested in is this idea of, can academic work that's done at universities spill over into the more commercial domain? And we're interested in this, I think, for two reasons. One, there's a lot of interesting work, some of which has been done by people who are in the room or have been in the room, that university-based scientific research is really important for commercial innovation and economic growth. And there's older survey work where they directly ask firms, could you have done this without the science that was done in universities? And firms very consistently say, no, that work was critical for the innovation that we did. At the same time, there's also been work which suggests that this university research is very embryonic, in the sense that it would be very hard for a firm to just pick up the academic paper, read it, and implement. This work is so early stage, perhaps more of a prototype, that you might actually need the involvement of the person who wrote the paper in order to do something useful with it. And that fact was actually sort of very motivating for the Bayh-Dole Act. And so this tension is what we're interested in this paper. And so this is a big question. I'm going to say this paper makes a start. And we make a start by asking a more specific question, which is just, does where an academic discovery is made affect the probability that it diffuses out into the economy? So just to give you an example of what we're thinking, in 2016, Duke and Stanford spent a similar amount of money on basic research, close to $1 billion. But 9 startups were spun out of Duke that year versus 32 out of Stanford. So it seems like these are schools that are very research active, but one of them is doing a better job of pushing this research out into the economy. But is it really the case that Stanford is sort of doing something different than Duke? Or is it the case that just there's sort of different field specializations, different people are sorting to these different places, and that's really what's accounting for the difference? So as just trying to take a first step towards separating out these two theories, what we do is we want to just look at academics who move between institutions like Duke and Stanford. Then you can have this thought experiment of saying, let's hold the people fixed. Does the sort of propensity of their work to spill into the commercial domain change? So that's what we're going to try to do. And just to make this very concrete, I'll give you an example. So I'll tell you a little bit about a small molecule called DMN-TRE. So this is a small molecule that allows you to detect tuberculosis very quickly and very cheaply and very accurately. You can imagine there's a lot of commercial uses for someone who discovers this molecule in their lab. So this lab was actually discovered by a chemist named Carolyn Bertozzi, who has since won the Nobel Prize. She discovered this in her lab at Stanford. At the time, she had a PhD student named Mireille Kameritsa. And this discovery led to both an academic paper you'll see on the left and a patent filing, which you can see on the right. In addition, the two of them actually co-founded a company, Olilux Biosciences. Mireille Kameritsa became the founder and CEO. Carolyn Bertozzi stayed on the scientific advisory board. And so what's really interesting about this example is not just that they commercialized, but also that Carolyn Bertozzi moved. She moved from Berkeley to Stanford in 2014. And she's on the record with these very interesting and suggestive quotes. She says, Berkeley was a great place to do basic science, great graduate students, top notch, but it was really hard for me when I was there to think about how to translate ideas into the clinic. You can contrast this, and by the way, when she was there for over a decade, she founded one company. She moves to Stanford. Within 5 years of moving, she starts 4 companies. And she says that she attributes her entrepreneurial fervor to the natural collaborations that bubble up at Stanford in a way that they didn't at Berkeley. So really what we're going to try to do in this paper is just assemble at scale examples of people who moved like this and see whether we can detect changes in sort of their ability to push their work into the commercial domain. Okay, so one thing I do just want to highlight at the outset is that when people move, they move to a new university, they also move to a new geographical destination. And so when we talk about a place effect, it's very hard for us to separate out, is this sort of something about policies at the university, or is this something about the geographical location that this university just sits inside of? In other words, is this something special that Stanford's doing, or is this a product of being in Silicon Valley? So I just want you to think that when we talk about these place effects, we are talking about the combination of these two. You can imagine there's some special cases like moving between Stanford and Berkeley or Harvard and MIT where to some extent you're holding the geography fixed. That's an avenue we have not sort of fully taken advantage of. With that caveat in mind, we estimate that roughly 15 to 25% of the variation you see across universities in terms of their effectiveness of getting their research out into the commercial domain can be explained by place-specific factors rather than sorting of individuals. Okay, so I'm going to talk quite a bit about data and measurement, and then from there we can start looking at results. So we need to start by measuring just the underlying academic research itself before we can measure it spilling out into the commercial domain. For that, we're going to use Web of Science. And then building on the work of Kevin Bryan, who's here, and co-authors, we are going to try to, our main measure of spilling over is going to be whether patents are citing this academic work. And so one thing that we can do sort of relatively recently is we can look at both patents that show up on the front page of the citation, but now thanks to really incredible work by Marks and Fuegi, we can also look at patent citations embedded in the body of the patent text. Our primary outcome is we're going to look at both. In the appendix of the paper, we're able to look at the two separately. We have additional measures that I will just briefly touch on here. We can focus on patent citations that come from companies which are VC-backed. You might think those are particularly innovative. We can look at patent paper pairs, which are these sort of special cases where a researcher publishes a paper and files a patent for the same discovery in a very tight window of time. And we can also look at membership of these researchers on scientific advisory boards. Okay, so that's step one. The next measurement challenge we have is trying to track researchers' moves across time. Now, this is sort of more challenging than we expected it would be for a very particular reason. So Web of Science gives us people's affiliations. So in principle, this could have been straightforward. But what you see is that in the sciences in particular, people have a lot of affiliations. So if you look at the last author on this paper, Sangeeta Bhatia, in this example here, she has 5 different affiliations. Actually, the order that they're listed in is not particularly meaningful. It's more to do with just the affiliation. You can just see these numbers are put on just sequentially in terms of the author ordering. So without a lot of expertise, it's very hard for us to parse which of these 5 affiliations is the main one. We might come up with all these sort of false moves if it's just people changing the order. So this was a big challenge. The way we decided to solve it is that while people have multiple affiliations, the corresponding author has a unique email. And so you can see that in red at the bottom. She says her email is at mit.edu. That lets us see that, okay, despite the fact that she's at the Broad and Brigham Women's Hospital, we think her true home is MIT. It's sort of a revealed preference of what do I view as my primary affiliation. So that's how we're going to try to code these moves. So in particular, we try to find as many of these email addresses as we can to build a panel of your email addresses. We do our best to fill in gaps in a reasonable way, but if we see that in 2 consecutive years, your email address changes and then sort of remains consistent after that, we'll code that as a move. A few additional just points about the sample. We drop people who move more than once. We really want to focus on people in the biomedical sciences, so people who are publishing in PubMed. This leaves us with about 14,000 researchers who are moving. The other fact, just to keep in mind, since we're using email addresses, this is sort of a sample that's, we have much more coverage sort of as time goes on. 2010 and afterwards is sort of when we have our best coverage. Okay, so those are the 2 big measurement challenges, and now actually we can start looking at some results. So I'm just going to show you some descriptive statistics to convince you that this methodology we have is picking up reasonable things. So the first thing, this is just some summary statistics about people in our sample we code as movers versus non-movers. The main thing to take away from here is that the movers are very different. In some sense, this is partly mechanical. In order to code you as a mover, we need to see you consistently publishing in the data. So that means that we're much more likely, if you're productive, we're much more likely to successfully code you as a mover. So don't think of these two groups of people as necessarily comparable. And our main analyses don't use the non-movers as a control group. We focus in on these groups of movers. Okay, this is just a figure meant to try to convince you that this measure of moves that we have works pretty well. So what I'm plotting for you here is the share of publications attributed to a researcher that come from their destination origin. So you can see prior to the year that we code as a move, we're not seeing them publishing at the destination. After the move year, we see them very consistently publishing at the destination. So I think we're doing a pretty good job here of getting sort of actual permanent moves. Another interesting figure we can show you is that where these citations are coming from in terms of geography changes around the time of the move. And so in green, you can see citations that are geographically originating from the destination. Those really increase right around the time that the person moves. Citations from the origin sort of smoothly decrease over time. That's interesting. It's also, I think, a helpful confirmation that, again, we're sort of picking up what we think we are. Okay. So now I can show you some descriptive statistics. So the first thing I'll show you is just that patent citations accrue very slowly over time. So this is saying that, 5 years after the paper is published, the paper has received about half of the patent citations it's ever going to receive. So it takes a while for these papers to start getting cited by patents. And that's going to be a challenge for us, because when we want to use an event study, you'd really like an outcome that changes very sharply at the time of the event. And this outcome is going to be a little bit fuzzier in that way. So let me just try to walk you through what I mean by this very specifically. So our outcome is going to be citations to this paper in the 5 years after it's published. This is just a sort of invented graph saying, let's imagine somebody who moves in the year 2000. And the x-axis is indexing the year in which these papers are written. So because our outcome is these cumulative citations over 5 years, papers that are written in the year 1997 are allowed to accumulate citations in the year 97, 98, 99, 2000, and 2001. So what does that mean in terms of this pre-post that we have in mind? It makes things a little bit confusing. 1997, the year the paper was written, is very clearly pre-move, but some of these citations are building up after the person moves. So how should we think about this year, 1997? Is it a before or is it an after year? It's a little bit ambiguous, and these colors are just trying to make that point clear. So this was a challenge that we ran into. So one way to address this challenge is, can we come up with an outcome that's more contemporaneous than 5-year patent citations? And so one thing that we do is we just realize that the journal in which your paper comes out is actually highly predictive of how many patent citations you're going to get. And so one thing we can do is just use the journal of publication to predict these 5-year patent citations, but we don't need to have this outcome that takes time to accrue. So we do that in our main results. An important interpretation point about this is that it restricts us to observing an effect that operates through this channel of people repositioning their research into new journals. It could be the case that even holding the journal fixed, there's still an effect beyond that. Using this predicted methodology is not going to allow us to see that. So in the paper, we do this multiple ways, but just given the results I'm going to show you, I just want to highlight this interpretation point. Okay, so then this lets us generate our first sort of stylized result. This is just a very static graph. But what it's showing you is on the x-axis, it's showing you the size and direction of the move. So if you're on the right-hand side of this graph, you move from a school that commercializes less to a school that commercializes more. If you're on the left-hand side of the graph, you move from a school that commercializes more to a school that commercializes less. So the x-axis is sort of the size and direction of your move. The y-axis is just the pre-post in terms of how many patent citations your work is getting. And so this is just showing you in a static way, people who move to a university that seems to be better at commercialization see their own work being commercialized more, and people who move the opposite direction see their own work being commercialized less. So this is very sort of suggestive. The last set of results I'll show you tries to do this in a more dynamic way with an event study so we can actually look at things like pre-trends. Okay, so the data generating process we have in mind is that we have some outcome that measures the spillover of commercial research. So in these figures, you can imagine that it's these predicted patent citations. And we're going to say that this is a function of an individual fixed effect, a university or a place fixed effect, and then some sort of calendar year fixed effect. So the big assumption here is that the person effects and the place effects are additively separable. One thing that's going to be very important here is when we're trying to run these event studies is this idea we want to scale by the size and direction of the move. Just to explain this, you can imagine a very simple thought experiment where you only have 2 schools and 2 researchers. We have school U and U prime, and let's say that U prime commercializes more. If you have one researcher who goes from U to U prime and experiences an increase in commercialization, and the other one goes from U prime to U and experiences a decrease in commercialization, those effects could be very big. But if we just plotted the raw means for both of those people in an event study, the 2 effects would cancel each other out and you wouldn't see anything. So what we want to do in the event study is we want to scale by are you moving up, are you moving down, and by how much. So what we do is for every author who moves, we compute this delta, which is just the sort of meant to exactly capture this size and direction of the move. It's just the mean of commercialization at your destination minus the mean commercialization at your origin. I can plot for you at the author level what these moves look like. And what's actually very nice is that you see people really do move in both directions equally likely. It's not that people systematically move to schools that commercialize more or less. It seems to be actually quite balanced. And so then we can actually define our estimating equation, which it's sort of very much what you would expect to see. We have an individual fixed effect here. We have these theta relative year fixed effects. The only twist is that we scale these relative year fixed effects by the size and direction of the move. So what the theta is capturing at the relative year level is the share between 0 and 1 to which you have converged to your destination. And so what we should expect to see, although we are not constrained to see it, is that the thetas should be 0 prior to the move, and then should go up to something between 0 and 1 after the move. And that will tell us the degree. So if they fully adopt the commercialization propensity of the new school, the thetas will be 1. If they adopt 50% of it, it will be 0.5. Okay, and so that lets us look at this first event study and sort of be able to interpret it. So what you can see is in the pre-period, the pre-trends are pretty flat, which suggests that people are sort of not moving because their research trajectory is changing, which is nice. And then after the move, we see that the coefficients increase to sort of somewhere around 0.25 to 0.3. So this suggests that about 25 to 30% in these figures of the commercialization of the destination that is adopted by these movers. We can split the sample into people who move to schools that commercialize more on the left and people who move to schools that commercialize left on the right. Sorry, commercialize less on the right. And what's interesting is that because we scaled by the size and direction of the move, remember, up just means convergence. It doesn't mean that these people are necessarily converging more. But it's interesting to see this symmetric response. Because you might think that once you learn how to get your work out into the commercial domain, even if you move to a school that does less of it, you wouldn't lose that knowledge. But this actually suggests that the effect is very symmetric. We found that interesting. Here we can do these results again using the observed patent citations rather than these predicted citations. We gray out this period here because this is this sort of blurry, is it pre, is it post period? But the results look roughly similar. We have some additional outcomes and robustness checks that I'll refer you to the paper for. The last thing I'll just touch on here, what we really wanted to do as part of this whole empirical exercise, we're able to estimate at the school level fixed effects for sort of which schools are the best at getting work out and which schools are the worst. And we thought it would be very interesting and make this paper much more policy relevant if we could correlate this with sort of features of these schools or perhaps the local labor markets that they're in. Unfortunately, we have between 200 and 300 schools, so we're a bit underpowered. Here we're showing you sort of the univariate correlations with all of these different features, and then on the right we're showing you a regression where we put everything in, let Lasso pick what is significant, and then the post-Lasso OLS. So these results are not, at best, they're suggestive, but they suggest that having a technology transfer office that's productive and executes a lot of licenses maybe helps, and perhaps being in a local labor market with a lot of VC activity is helpful, but I would say these results are suggestive at best. So with that said, I'll just conclude. These results suggest to us that places do matter. We think places explain between 15 and 25% of the variation that we see and whether university discoveries spill over into the commercial domain. And sort of preliminary work is trying to figure out why these, can we understand better what drives these place effects? But I'd say that work is still ongoing. Thank you very much. Sorry for going a bit over.
Yeah, I also would like to start by thanking the organizers, and particularly Adam and Lee and Philippe for allowing me to be here. I enjoyed every minute of this conference here. It has been a frustration in all of my academic life to not have been able to meet Zvi personally, but from all the stories that I heard today, I now realize that I do have benefited a lot from indirect spillovers through what I see as very similar characteristics in his sons and daughters here. So this is a permanent effect of Zvi Griliches that will live through here. So let me start my discussion of this paper here. I really liked very much this paper here, and although it has a lot of pages here, unlike what Gaëtan was saying, I thought it was really very important that there were so many pages, and particularly on explaining the data here. That might sound a bit less interesting, but it's very important that these indicators are being very carefully identified here. So how do I, here. Okay, so I'm going to be very short in terms of, because Caroline did a very good job in presenting the paper here. So the key outcome variable is this commercialization of university research here, and it's basically measured by citations to patents. Although initially I thought it was going to be on spin-offs here, but it's mostly citations to patents here. And what I really want to do is to try to single out place-based factors from individual researchers' effects here, which is a very good research question here. And the way to do that is by trying to exploit any moves of academics across institutions here. That, again, I think is a really good idea here. And for that, then they trace these career movements of academic researchers across a number of affiliations, which are basically universities here. And what they find is that about 50 to 25% of this geographic variation in these citations to patents is due to what you could call place-based effects here, which it is sizable, but actually you have to remember that the big majority of the effect comes from the personal effect still here. So then they try to uncover a bit what these place-based effects would be here. So there are two. One is the university-specific effects, but the other one is the more geographic effect here, where they try to identify on the characteristics of the schools, the importance of stuff like the TTO and the licensing kind of stuff, and research funding, and on the local environment, the presence of local venture capital here. Also very much liked this case that they did with Bertozzi, which really shows how such a move of a top researcher can actually have a big effect here. So I go back to Adam's template on what Zvi would have liked, and I think this paper would really score high because it gives very interesting but surprising results, non-trivial results, and new. It's a very highly relevant issue here, and it's very much data-driven here, so it really relies on very careful analysis of data here. So, of course, I also agree with that. I'd like to start with this very careful data and measurement here. So again, the paper, you have to read a lot of pages on how they construct the data here. But I really like that because it's really very important that you do this very carefully here, because it really also allows, and you're also very critical of yourself. You're saying what are the strengths and the weaknesses here. So I think that's really very important here. I don't want to really discourage this here, so it's really good. So in terms of measures for commercialization, but I will be very quick because you did a very good job on that. So You really focus on the citations of patent publications, very carefully also identify front pages and in-text, although it doesn't seem to matter that much in terms of what you were actually using here. And it's not actually the actual numbers, but the predicted numbers of scientific papers, so it allows you to correct for things like the quality of the paper and stuff like that, so really very good. Then you also go a little bit into detail of certain other cuts in the data, like patent paper pairs here. And also what I really liked was this data on membership of scientific advisory boards, because these would be really alternative mechanisms for commercialization, like for the spin-offs here. Unfortunately, the data were not that well, the empirical measurement of that was really very difficult, but that's a bit unfortunate here. But that's not up to you. It's up to the quality of the data. Then, of course, what's also very important is this critical measure of moves, because that allows you to try to identify place-based versus individual effects here. And again, you went through a very careful analysis of doing this through the emails. Something I found a bit puzzling was the fact that you only looked at universities through their TTOs here. Maybe that's in the US, and certainly for the top places obvious to do, but like here in Europe, there's also still a lot of activities going on beyond TTOs here. So I was wondering to which extent you really needed to have that restriction here. And then trying to identify these place-based factors here, so you have some information on the TTOs, through the TTOs on how much funding they get and their licensing agreements as characteristics here. And then for the place-based factors was the venture capital-backed firms here in the patents, which was no surprise given your courses that you looked at this. So I really like this very careful analysis of the data here. Really helps you to put in perspectives the analysis that you're doing here. But of course, it leads to a big attrition of the data here. So you showed it in the paper too. On top of that, in the end, you actually restrict to biomedical research here, which I think is also very important. It's a good selection because in biomedical, there is a very clear link between publications and patents here. But of course, it leads to a certain, well, not bias, but at least sample selection that you might need to be careful about in terms of the external validity of your results. Another thing that really also, I think, should be emphasized more from the start is that the data that you will be working with are very skewed here in terms of, so these, for instance, and the selection with the movers have more publication, and for that they will also have more patent citations to papers here. So that's already also a sample issue you need to discuss, but you do, but more from the start. And then also this concentration on few researchers that have this likelihood to be showing up their research and patents, and also concentration in these top commercializing universities and locations here, and what the implication is of that concentration here. So then if you look at the major findings here, so as you also very nicely illustrate, how you try to decompose this firm fixed no, not firm fixed effects. So the individual fixed effects and the location fixed effect. So you emphasize quite a lot the importance of this place-based effect, but actually the overwhelming part of the story is in the person-specific effect here. So this is what I found actually as that means we really need to work more on trying to understand that inventor-specific effect here. And furthermore, I was wondering to which extent the way in which you can construct also these moves as a way to try to identify these two different effects here. So you really need to have that these moves are not related to any fixed effect here. So that the fact that they move is not due to the fact that they have this great idea here. You say you analyze pre-trends, and if there is not much movement, that would suggest to that, but I'm still wondering whether, even if there is not much movement pre-move here, but then suddenly you get this great idea, and actually Bertozzi is a bit of a kind of example of that. So she really got this big idea, and maybe because of this big idea, she decided to switch to Stanford here. So in that respect, I think you really have to think a bit more carefully about these moves, and whether they are really how endogenous they would actually be here, an occurrence of 2 minutes. Yes. And then you unpack these, you also show this place-based effect here. So again, returning to Adam's likely Zvi comment, so the thing is, do we really, so it's really great in terms of measurement, but it then raises the question, do we really understand what we're measuring? And here, I think you open up the floor and for lots of further on research here, trying to understand better what we are measuring. I already highlighted the fact that we need to really unpack these big person-specific factors here. So that's, for me, the major conclusion of your result here. That's what we really need to, that's where the majority of the explanation actually is. And on top of that, even of this place-based effect, how much of there is there in the interaction between the two here is that the extent to which individuals really try to exploit any differences there would be here. So I was a bit also wondering whether your title of scholars really wondering, so because wondering seems like a bit of a randomness here, but I'm not sure that they actually are wondering here, so I think you need to. And then also in terms of, even if you have these place-based effects and university effects, to really try to understand better what they would be here and how they would interact here. And I was really a bit annoyed by, I Googled up how others, but actually on Facebook, were using your results here. And they came up with incredible implications from your paper, suggesting we have to invest in technology transfer offices, and that doesn't at all come out of your analysis here. So I think in order to really preempt all these kind of policy implications others would draw from you, you would have to invest very quickly more in what you can measure on this and not. But great paper. Thanks.
Let me just say, I won't address everything. That was a great discussion. Thank you so much. I think the most important point that Reinhilde brought up is this endogeneity of moves, which I just want to say is something that we also worried about. So the concern would be that these person effects are not time invariant, but rather I develop an interest in commercializing and then seek out and move to a school that's going to help me do that. And so we're still grappling with this issue. I think one thing that gives us a little bit of comfort is that it seems like faculty are not always so aware. So for example, there's actually an interesting survey which suggests the vast majority of researchers don't know the revenue sharing rules at their own university, let alone a prospective university they might move to. But one thing and I think what we're trying to argue is not that moves are random, but that moves are predicated on sort of other things that are uncorrelated with the change in commercialization. But one thing we're thinking of doing, and would just be curious to see if it would help, is perhaps just fielding a very small survey, taking a subset of the people we code as movers, and asking them to rank across a series of factors what was the reason for their move. And if we see that it has much more to do with personal family circumstances, prestige of the university, which is actually quite uncorrelated with this commercialization measure we have, that could maybe help bolster this argument, but that's just something that we're working on, so I wanted to put that out there. Okay, yeah, now happy to take questions.